Welcome. This is Chapter 5. Chapter 5 is kind of sort of like a continuation of Chapter 3, and quite frankly, there really isn't that much new material as compared to Chapter 3. I guess Chapter 4 was like to give you a nice break with, ooh, pretty pictures, and now we're back down to the hard stuff again. So, as always, we're going to start with the chapter objective. So, turn to page 253, and let's get started. It talks about the if function. Yeah, you should nod your head thinking, yeah, we did that in chapter 3. Build nested if functions. Conjunction functions. We'll describe what that means in a minute. Conditional statistical functions. Conditional math functions. Conditional database functions. Explore the lookups. And retrieve data using match, index, and indirect, and then doing errors. Okay, so before we even get started with the textbook stuff, let's talk in general terms about what we're talking about. What is a logical function? Well, a logical function is anything that resolves to a true or a false. That's the simple definition. It works pretty well. So there's lots of these things. I mean, in the real world, if I was to have a something, oh come on, now's not the time to be pokey. So if I was just to go here and just say, I just start typing, you know how you do a formula, right? I can just say, I don't know, say is 5 greater than 2? Okay. Well, that should be fairly obvious that it's true. So 5 greater than 2 resolved. Sometimes I say return, but resolved to true. There's a bunch of operators. I mean, there's the less than operator, the greater than, the less than or equal to, and the greater than equal to. And I mentioned to you guys before, back in chapter 3, that anytime you have a combination of symbols, the equal sign is always to the right. Okay. Equal sign, which is, you know, are two things equal. And this is a weird one. This is not equal to. I know it's kind of an odd one. A couple computer languages use that, but it's still a bit weird. So not equal to. And then there's an and operator and an or operator, and we'll get to that in just a little bit more detail. So over here, I'm gonna put a. Let's go someplace else. I'm gonna put over here and put a 5 and a 3. And so I want to know if the thing in I4 is bigger than this thing in I5. Okay, so one more time. I'm just going to say, you know, I5 greater than I4. And the answer is, obviously, it is true that that's. So let's do it the other way around. I'm going to say, you know, less than, you know, greater than or equal to. And obviously it's still the same. How about less than? Cool. I'm sure this all makes sense. Okay, so that's what logical operators are all about. So this notation should be fairly obvious. I think the only one that may give you any trouble at all is the not equal to thing. Okay. We are going to talk about these things. They call them conjunction functions. I call them, you know, just logical operators. Or the only problem is it's kind of hard to tell the difference between that kind of logical operator and that kind of logical operator. So they call them a logical function or a conjunction function. Okay. So on page 257, we finally start talking about the if statement. So the if is a logical test. So right off the bat, what is a logical test? Well, a logical test is something that returns a true or a false, right? Okay. But often I want something more. I want a word in here. I don't want it to say false. I want to say, yes, it is greater, or, you know, whatever the scenario is. I don't want the word true or the word false. I want my own words in there. Okay. So to do that, you use an if statement. So the logical processing part still remains. It's just the technique you use to substitute your words. So I'm going to say equal if, and then open the parentheses, and I'm going to put the test in there just like I did before. I'm going to say I4 greater than I5. Okay, now first of all, you should be able to tell that this is going to come out true, right? Because I5 is greater than the value, I'm sorry, I4 is greater than the value of I5. So if has three parts to it. The first part is that logical test. And remember, logical test always is a yes or a no, or a true or a false, okay? And then the comma is what I would like to substitute. Instead of just the word true, I want to have something else there. Okay, I could have words here. I could say, yes, it is greater. And then the false would be, nope, it's not greater. Oh well, spelling doesn't count here. Okay. So what I've done here is I basically just told the if statement, instead of producing the normal generic junk, I'm going to have it substitute some words that I want. I'm going to do that again. In fact, I'm just going to grab this guy and drag him down. Okay. So let's try this one more time. So this is I4 and I5. Instead of words here, I'm going to put numbers in. I'm going to say 42. Okay, so it doesn't matter if some of them are strings and some of them are you know, that part doesn't matter. So let's do that again. So this time I'm going to do something slightly different. Instead of using numbers or text, I'm going to put something funky in there like date. So I say, if I4 greater than I5. And then I'll put a date. You guys remember how you put a date inside this thing? Remember this thing called date value? Because you can't actually type in, you know, let's do 12/25/2015. And then over here we have another date value. I don't know what. Let's do 1/1/2016. Okay. Okay. Now, obviously it didn't format it as a date, but that's not really the point. I guess I could go here and say, yeah, I really want the date here. Yay. Okay. The point of the story was that inside this if statement, you can have nothing, and it'll default to what the true and false. You can put numbers in there. You can put text in there. You can put cell references in there. So the if statement is pretty doggone powerful. It's just three parts. Some sort of a logical operator that resolves to true and false, and then what do you want to do if it's true, and what do you want to do if it's false? Okay, so it's really, what do you want to do? There's a figure 1 on page 258 that kind of talks about the so-called decision tree. If you get a little confused about, you know, you're going and you have a path, you know, one goes to the right, one goes to the left, or one goes to true, one goes to false. So that's how a decision tree works. Okay, on page 258, they talk about, you know, creating an if statement, which is what we just did. And remember, when you start one of these suckers, it always starts with an equal sign, right? And there's a complex example that they use as, you know, so here's a complex one. Because you remember now, this is the if part, and then here's some up to the comma is something that's going to resolve to true or false. Doesn't matter how complex it is. So in this case, sum B5, B20 is greater than sales target. Obviously that's a named range. Comma. Okay, so that means if the sum is greater than target, then if it's true, they get 0.03, which I suppose is probably like a decimal percentage. And then if it's false, they get no bonus. So you can mix. In this case, we're mixing what is most likely a percentage for true and text for false. So that's how this is supposed to work. Okay. You can remember all of the rules from Chapter 3 when entering numbers in a function. If you don't remember that, at the top of page 280, they kind of go over them again. And it's pretty straightforward. You remember we talked about how entering, like in that case, entering percents, you have to go in and use the decimal conversion, and dates you can't enter except with this date value thing, and all sorts of crazy things like that. So anyway, unfortunately, when you're in one of these formulas like if, you have to kind of translate in your head the thing. There's no percent signs, there's no dollar signs, there's no commas. those kinds of things. Okay, the next thing on page 261 is we're talking about a nested if. And this is one of those scenarios where you might think that there's a range of issues. Let's say, for example, that, I don't know, you're doing fasting blood sugar. And so somewhere you have something that says if it's less than 60, that would kind of sort of be like low. And if it's 61 to, I don't know, 120. I'm making these numbers up. Somebody has diabetes. You can tell me that I'm bad. Normal. Let's say 121 to 170 is high. And then anything greater than 170 is very high. Now, we have done this kind of an issue before, and we use a lookup table. Remember that? Well, we're not doing it this time. Now we're going to be using a nested if statement. Now, there is some philosophy behind how to approach this. And so first I need some data. I'm going to do something cheap. I'm going to do cool stuff. I'm going to use random, okay? Because random is a kind of a cool way of getting some good data. So I'm going to say, how about 50 to 200? Okay? And I'm just going to grab this guy and go, okay, now I've got some data I can play with. Cool? All right. So what I want to do here is I want to do an if statement that says if it's, you know, lower than 60, then is it lower than, and then is it lower than, is it lower, is it lower? So really, let's talk about what we're doing. I'm going to need a series of if statements. The first if statement, I'm writing this out here. It's not really a formula. It's going to be something like if less than 60. So that would be one of the conditions, right? And then followed by something like if, you know, greater, you know, if greater than or equal to 60 and, you know, less than 120. And then I need another one after that that says, you know, if greater than or equal to 120 and less than 170. And then I need another one that says if greater than or equal to 170. Okay, so can you see how there's actually 4 questions here? Less than 60, in that middle range, and then the next range, and then anything after that. So I'm actually going to have to ask that many questions. Now, oddly enough, you don't really need this much. If you do these things in the correct order, you can simplify this. So for example, if I say, if it's less than 60, and then turn around and ask it, are you less than 120? It's like the first true in this structure wins. So the first true wins, and then it just goes to the next one. So I really don't need this part. I can just say less than 120. That didn't work. Let's try that again. And this doesn't have to be that complicated. I can just do it this way. But we're not done yet. There's a way we can make this thing just a tiny bit simpler. So again, this goes in steps. If it's less than 60, it's going to stop right there, and it's not even going to attempt to evaluate anything else. If it's less than 120, it'll stop right there. It won't go any further. If it's less than 170, it'll stop right there. And so really, this last one I can just remove and basically say everything else. So what I've basically done is I have 4 zones here, but I only have 3 if statements. I've taken off the ands that I had to begin with, and I've scrunched them, scrunched them, scrunched them, scrunched them. So now there's only 3 conditions, 3 if statements to determine 4 ranges. Okay, this is probably a good place to start for the 15-minute mark. We'll pick this thing up again in just a few.